I'm doing my labs. I have no complaints whatsoever.
Someone else saying something? Okay. Taking time here.
Everything fine. We understand.
Okay. What we did last week? Protocols, right? So this week is table. All right, Sayed?
Yes, sir.
Table. Okay. So any question before we start?
Today's lesson's about cabling.
No, not about cable. About any other lesson you did, any other lab you were not able to do. Did you get time to watch the video I shared, CIDR notation and stuff like that? Yes. Okay, how many of you have started or attending any club? Any student club? How many of you start attending any student club? Do you know we have few student clubs? David, can you just give them an idea what club you are representing?
AITP.
Please stand. Yeah.
AITP.
Say it loud so that everyone can hear.
AITP.
Yeah, just give them an idea what it is and.
Okay, the AITP represents any sector of technology, whether that be networking, programming, cybersecurity, anything really.
And we will be inviting speakers, guest speakers in that club, or we have some club officers. They are going to share a few new topics which you may not be studying in your classes. Okay. And those who are, all of you, I believe, or all of you are either in cybersecurity major or in networking major. So I would highly recommend you to attend at least, you can attend WIT. WIT is Women in IT. Not just women or females, everyone can attend that club because the speakers coming in that club, they are going to talk about IT in general. And you can attend AITP, which is everything about IT. It's an association of IT professionals. That's what AITP stands for. So, and finally the ISA. ISA is your Information Security Association, and that is going to be about the cybersecurity. So even if you are not the cybersecurity major, then also you should know a few things about cybersecurity. Okay? Yeah. Where do you sign up? No sign up is required. You can go and attend the meeting. One AITP club meeting is today at 4 p.m. in the room number 104. 104 is dedicated for those activities actually. So if you have any seminar or any club meeting or any guest lecture coming, speaking to the students in general, so that will be in room 104. Tomorrow you will have ISA club meeting at the same time, 4 p.m. And I would highly recommend. That's all up to you. Whether what would you like to do with you, and it's a learning opportunity. That's all I can say. And a few things which we do not touch or cover in the classes, or you can get a chance to talk to some real people, or real people means those who are really working in industry. You can actually talk to them. I would recommend or suggest you, if you guys try to put your monitors below for the time being, like this.
Seriously?
No. So that I can see you. I can see your faces.
Sir.
No. Don't lift it from the monitor screen. Lift it from the base or the bar behind the base. Yes. Yeah. You can turn the face also. You can keep your face towards you if you want. Put it like this.
Yes, sir.
Move it a little bit. Those who are using monitor, you can turn it towards you. If you are not using it, then you can leave it as it is. Okay. All right. So if you do not have any question, then we will start the next lesson, which is cabling. And this is going to be a packet tracer, building a packet tracer network. I'm not sure how many of you have watched it, but let's watch it first. What we are going to do in this lab, in this simulation or activity. They are going to tell you how you can build a network, a simulated network using packet tracer. And what is packet tracer? Is it a tool or application or command or service? What? What it is? Huh? Application. So what is the use of this application?
We receive packets going to see where packets are going and coming from.
Where the packets going and coming from? Anyone else?
Servers.
We can create and simulate a network. Alright. And you can also create and simulate a network.
Hi all, my name is Jill West. I'm the author of the CompTIA Network Plus course from Cengage. In this video, we'll be working through the project Build a Packet Tracer Network. Now in this project, you start to build a network and packet tracer that you will continue to add on to in later projects and chapters as you learn more about network.
Let me tell you one thing, that if you are not comfortable or if you do not get hold of this application, you will face problems later. This is the high time that you get to know what this application is, packet tracer, and do some practice on it.
How do you get this application?
How you get that?
This application?
It's in the previous lesson. If you watch the videos and do the exercise in the previous lesson, then you will. How many of you have completed the packet tracer activity in the previous lesson? Mr. Syed, what
Yeah.
you're looking?
Sorry.
That's what you should look at every lesson and every component. That's why I'm running this video, because I know some of you are not very serious about
And in the end, you'll finish with a network that's more complex and more advanced than what you could have built in a single project. So let's get started. In Cisco Packet Tracer, we first need a router. So here in Network Devices and Routers, let's add this PT router to the network. Next, we need a couple of switches. So let's switch over to the switches group, and we're using this 2960 switch. So click here, grab a switch, and let's put one more over here. And next we need two PCs. So we're going to the end devices category, grab one PC, place it here, and a second PC over here. Remember, you're going to be building out this network and adding a lot of other devices to it later, so it's important to begin with the right structure from the beginning. We've got the router up here at the top, and the other devices are arranged kind of in a pyramid shape with the switches on the second layer and PCs at the bottom. Now we're ready to make some connections, so let's jump over to the connections category. We want to start with this copper straight through cable, and it's important to make sure you use the correct interfaces for each device. So choosing the copper straight through cable.
So when you are looking at it, you can read what it is here at the bottom. And the moment you place the mouse pointer here, you can read what this type of cable is. So it is given here, copper straight through. And you should understand what is straight through, what are the other types of cables we have, what is the use of it. And only you can select one and put it here. What kind of cables we need between the router and a switch and a PC. All those things are.
Cable. Let's start with the first workstation, PC 0. We're connecting to fast Ethernet 0, and then going to the switch, and we want the first fast Ethernet option up here, fast Ethernet 01.
So what does it show here?
Fast Ethernet.
Why we have so many ports here in the switch? Because that's what is available in the switch. So switch has multiple ports, whereas PC has just one or two, as you can see here.
Well, let's start with the first workstation, PC 0.
So you see that the PC has just one port, fast Ethernet 0. Whereas
So we're connecting to fast Ethernet 0, and then going to the switch,
switch has many fast Ethernet ports.
and we want the first fast Ethernet option up here, fast Ethernet 01. Same.
And it is not necessary that you should attach to the fast Ethernet 01 only. You can attach to any port, because the only reason is that you should remember where you attach that port, where you attach that PC, because if you are doing any kind of control or you are doing any security enablement on this switch, then you should know where your PC is connected to the switch, so that you do not block the wrong port, or you do not disable, or you do not block any incoming or outgoing traffic to the wrong port.
Thing with the other PC. So copper straight through, fast Ethernet 0, going to fast Ethernet 01 up here at the top. Next, we need to connect both switches to the router. So again, copper straight through cable. This time we want the second fast Ethernet interface here. So that's fast Ethernet 02. Connect to the router. And on the router, we're starting with fast Ethernet 0.
So on the router, you do not have many or multiple
Connect to
Ethernet
the
ports. You have very few Ethernet ports, and then you have some serial ports. You have some other, I could not read it properly, that fast Ethernet ports are there. But there are multiple ports in the router. Router ports are not only available for the networking, but also required for administrative purposes. And even in the switch also, you will see some administrative ports.
Fast Ethernet.
Right, so there are some gigabit Ethernet port, gigabit. There's a fast Ethernet port and a gigabit Ethernet port, which is connecting a very fast network, which is let's say coming from the ISP, Internet Service Provider. So, and there is a console port which is hidden on top, black color console port. This console port allows you to do any configuration in your switches. Okay. So
Option up here, fast Ethernet interface here. So that's fast Ethernet 02. Connect to the router. And on the router, we're starting with fast Ethernet 00. Then second switch, we need the fast Ethernet 02 interface, going to the router, and
now you can see what kind of ports we have in the router. Auxiliary port, console port, fast Ethernet. One was used in this, other one is available here. Then we have two serial port and another port we have for fast Ethernet, but those are, I believe these are for fiber optic. This port which is used for fiber optic through Ethernet. we are calling them conversion ports. So actual cable we are using or connector we are using is made up of fiber optic, but it is used in Ethernet data transmission. So these are different ports. Now, what is the use of console port? Again, for the management point of view, you use console port, and for normal network operations, you use Ethernet port. For serial port can also be used for administration, but depends on, because serial ports are of 9-pin ports. Have you seen any serial port ever? A serial port. Let me show you what serial port is.
No, that's not in a long time.
It's a 9-pin serial port.
I've seen these before, not in a long time.
This one.
Yeah.
Right? You must have seen this many times, but I don't. Maybe you don't know it as a serial port. Right? It is a serial port, and it was also known as VGA port before, because we used to connect the monitors to this port. In long back, the mouse, when the mouse first came, the keyboard, when it was first came, all were connected through serial port only. So in computers, there was only two types of ports, a 9-pin port and a 16-pin port. 9-pin port used to connect all kinds of devices, monitor, keyboard, mouse was not there. Then 16-pin port was used for printers, all printers. Then PS2, PS came, PS port, PS1, PS2 for mouse and keyboard. Then came all the other USBs, and since the USBs, everything has changed.
Second, fast Ethernet interface, fast Ethernet 1.0. If they're not already green triangles, wait for just a minute so the orange dots will turn to green triangles, and you can...
What is green triangle represents? This green? Online. So port is connected and online means this is powered, the switch is powered on. So you don't need to connect the power cable here in the switch. Otherwise, switch, routers, everything need a power also. They don't work on its own. They need a proper power connection. Okay?
Reposition these devices so you have straight lines and looks nice and neat. Now we're ready to make some configuration changes. Let's click on router 0 up here at the top. We want the config tab. Now we're going to be what you are trying to do is you are trying to make some configuration changes in the router. So when you are doing configuration changes to the router, you need to connect the router using config port or console port or serial port. Now either console port or serial port, either of those two works. But most of the engineers now using console port. They don't use serial port, because in order to connect to the serial port, you have to be in the network room where the devices are located. Then only you can connect your laptop or your machine to the particular device using the serial port. But if you are using console port, then what the engineers do? They used to build a separate network only for console operation. Means there is a network where all the devices are connected to a console network, and there is another network where all the devices are connected for data transmission. That means if you look at this picture again and change here, this network is only for data transmission, because all the cables are connected to fast Ethernet. None of the cable is connected to the console port. If you connect a cable to the console port of this switch or this router, and all of these, means all three are connected, a cable is connected to the console port. So what you can do is you can build a separate network where you can do only administration of those devices. That will be a separate network, separate IP address even. Listen, data travels in one type of network, but administration happens in other type of network. We should also understand in this way that our network is divided into two parts always. One is data network and another one is
what this short form is? Management network. So one is data network, another one is management network. Data network always depends on the client services you are running. Management network, which is internal network, where you are doing all kinds of management stuff to your on your devices. So your devices can have different IP address. One IP address belongs to data network, another IP address belongs to management network, and that IP address always goes to console port. Always goes to console port. If you want these PCs should be part of your data network as well as the management network. How can you do that? You need two NICs or two network interface cards in these computers. Then only you can put your device into two different networks simultaneously. Okay. Though, can I assign two IP addresses to the same NIC?
No.
One question. Can we assign two different NICs to the same NIC? Two different IP address to the same NIC. These days it is getting possible because of virtual. You can create virtual NICs in your computer. You have an NIC, you have one NIC in your computer, and you can create another virtual NIC. Third virtual NIC, fourth virtual, multiple virtual NICs you can create in your computer, which is you will see sometime later.
Let's click on router 0 up here at the top. We want the config tab. Now we're going to be
So this window is only possible when you are connected to this router using console port. This window, what you can see here, this is an administration window for the router, is possible when you are connected to the router through console port or through serial port. See, you need to understand that difference between the console port and the serial port is, for the serial port I need to be in the room, in that room where the device is located, because serial port cables are not long. They are not long enough. They are maybe 3 feet or a few feet cable only. But console port is a networking port. So you can be anywhere in this world. Anywhere in this world you can control your switches and routers because those are connected through the network. Okay. So it is like, this is your management network, and this network is in California. You are sitting in Atlanta. You connect to this network via VPN, and now you are the part of this network and you can do whatever you want. So networking is making this thing possible and smooth everywhere in this world, and because of this only you are now able to do remote work. People are doing remote work for different countries, sitting in one country.
making changes in the GUI, the graphical user interface, but keep an eye on the equivalent iOS commands pane down here at the bottom so you can start to get familiar with some of the Cisco commands that we'll be using in later projects. We first need to make some configuration changes to fast Ethernet 00. Remember, this is the connection on the router that goes towards this switch 0 and then onto PC 0. Remember to keep an eye on the commands down here at the bottom. We need a static IPv4 address. We're using 192.168.0.1.
What you are doing very easily with a graphical user interface, it wasn't there before. Few years ago, it was all command line. Everything was on with the command only, no GUI or no graphic interface like this. So it's much easier now because you can see what you are doing. You don't need to type any command. You don't need to remember the command. But what she's telling you here, that you can see
Towards
the
this
commands
switch.
here. You can see the commands here at this part of the window. What command is executed once you are doing this job here? a job you are doing here, a command is executing in the background. Alright, so that's what it is saying, that keep an eye on this bottom portion, because certain things you may need to do through commands.
This is a Class C
Right, so this is assigning an IP address to this router.
IP address. We need a Class C subnet mask 255.255.255.0. Notice the commands down here.
Notice the command. Notice the command, how the IP address can be assigned to an interface. First of all, you are going into an interface. So your command is interface fast Ethernet 00. So you are going to you are basically trying to change the configuration of fast Ethernet port number 00. See the prompt, how the prompt has changed. The prompt is config. Now when you say interface fast Ethernet 00, the prompt has changed to config if. Config if. And even if you go before, your prompt was router followed by this angular bracket or greater than sign where you type enable. Then you get this prompt where the hash or pound sign is there. Then you say config terminal. Configure terminal. Then you get the new prompt, router config. When you say interface Ethernet, fast Ethernet 00, then you get this new prompt. Now you are, whatever command you are executing, that goes directly to this port.
You can see where we configured the IP address and the subnet mask. Now we're ready to turn the port on. So just check the on box here next to port status, and notice the state has been changed down here in the command line. So change state to.
What is the command to turn the port on? No shutdown. And let me tell you that these commands are also support acronyms or a partial command. You don't need to type the full command. You can just type the first 4 letters of the command. If the command has less than 4 letters, then you have to type the full. But if the command has more than 4 letters, then you can just type first 4 letters. So no shut. No shut would be the command. If I say configure terminal, so config term, config is not the command, config term, because there are other commands. So if there are multiple commands with the same name, starting with the same name, then you may need to type more letters, more than 4 letters. So it's not always 4 letters, and tab also works. So you can just press the tab key to complete the command. It will automatically pick up the right command for you. And you can keep pressing tab if you, let's say, there are more than one commands starting with the same letter, so you keep pressing tab and until you get the right command. So that way you can.
Let's do the same thing with fast Ethernet 10. We need an IP address, and this time we're using a Class B IP address, so 172.16.0.1. Tab to the subnet mask field, and
you notice that assign one Class C IP address to 00 and Class B IP address to 10. Means both the ports are on different networks. Both the ports are on different networks. So you basically, what is your design? You remember the design? There is a router, there is a switch, then there is a PC, then there is a PC. So this side is going on Class C network, this side is going on Class B network. And remember that when you have 2 different types of networks, then you need a router so that they can talk to each other. Every time there is a different network, you need a router for establishing communication between the 2 networks. It is something like, it is exactly similar to that this person is speaking in Spanish and this person is speaking in English, but they cannot understand each other, what they are speaking. So they need a translator in between or an interpreter in between doing interpretation of the communication.
Packet tracer correctly guesses it's a Class B subnet mask 255.255.0.0, which could also be written as a /16 IP address. Notice the commands down here. We went into the interface configuration mode and we configured the IP address and the subnet mask. We're now ready to turn this port on, and we're finished with the router's configuration. So you can wait just a minute until this last orange dot turns to a green triangle, or you can go ahead with PC 0. Just make sure that this is a green triangle before you continue with PC 1. Clicking PC 0, let's make some configuration changes here. We're going to the Desktop tab, the IP configuration tool. We want a static IP address, and then for the IP address, we want 192.168.0.100. Tab to the subnet mask field, and it is a Class C subnet mask, 255.255.255.0. For this project, we also need a default gateway address. So next to default gateway, let's give it the IP address of this interface on the router, which is 192.168.0.1. Now, when you make configuration changes to devices, it's a good idea when you have the opportunity to go back and check your configuration through some other format. So we're going to close the IP configuration tool, not the entire PC configuration window, just this IP configuration tool here for the desktop. And let's go to command prompt. Here you can run the IP config command, and it confirms the configuration that we just implemented, 192.168.0.100 with a Class C subnet mask and the default gateway 192.168.0.1. This looks good. Let's jump over to PC1. We now have green triangles all the way through. Clicking PC1, move that over just a bit. We want to go to the Desktop tab and then the IP configuration tool. Static IP address, we're using 172.16.0.100. Tab down for the subnet mask, and it guesses correctly. It's a Class B subnet mask, 255.255.0.0. One more piece of information here. We need the default gateway going to this router interface over here on the router. That was 172.16.0.1. Again, we want to close the IP configuration tool and jump over to the command prompt first so we can check our configuration. So IP config confirms our IP address is 172.16.0.100, and we have a Class B subnet mask with a default gateway of 172.16.0.1. Next, let's test if our PCs can talk to each other now. Could we send a ping from PC1 through the switches and the router over to PC0 and get a successful response? So let's try it. Pinging PC0, which is 192.168.0.100, and press enter. The first ping message might fail, and that's okay, but the rest of them should be successful, and that's what we have here. So the first one failed, but the next three were all successful. If this is not the case for you, make sure you take a few minutes to troubleshoot the problem, reconfigure whatever devices need reconfiguring, and keep at it until you get a successful ping from PC1 to PC0. One of the neat things about Cisco Packet Tracer is that you can put it into simulation mode and then watch the packets as they're going across the network from device to.
So Packet Tracer is not just a tool where you can see packets are moving in one direction or in one PC to other PC, but Packet Tracer is actually created to simulate your network design. Someone wants to create a network between these two PCs. They are both using different IP addresses. Different class of IP addresses connected to two switches. And now they want to communicate, or they want to establish a communication between these two PCs. So when you are proposing a design of this type of network, then you need to test it, because you can't just build a network or build something which you not tested yet, right? So that's the Packet Tracer gives you an opportunity where you can create a similar network virtually and test it. Once you tested it, then you can implement the same network in real time. So that's how the Packet Tracer is designed. Now, rest, you can do many things in this, like you can test the packets, you can send packets between the two PCs, test the packets and all.
Device, and then dig into those packets and see what makes those packets work. What are the packets doing? What information is included in them? So to do this, we're going to turn on simulation mode. Click simulation down here at the bottom. This opens the simulation panel. You might need to resize your window so you can still see your entire network here, and then see the simulation panel. I'm also going to make this a little bit taller because we want to be able to see the packets that are listed in this event list pane right here. Going back to PC1's window where we have command prompt open, arrow up to retrieve the most recent command, ping over to PC0, and press enter. Now because this is in simulation mode, it won't immediately begin. It's waiting until you tell it to play the simulation. So go back to the network's main window and click the play button in the simulation panel. Notice that the packets start to move across the network. It goes first from PC1 to switch 1, pauses, goes from switch 1 to router 0, pauses, and then keeps on going. Every jump that it makes, we're collecting another packet over here in the event list. You can let this run for several seconds so that it has multiple messages running across the network. When you're ready, you can click pause, and this pauses the simulation. You could continue to play whenever you're ready as well if you want more of these messages collected, but this kind of freezes the activity so that you can evaluate the information you've already gathered.
Alright, rest you can watch yourself. Now, I'm going to show you some networking devices if you have seen it already or not seen it, but I want row by row. First row, come first. Here.